Welcome all. Today we are going to take this part of unit number 4, which is named as lithography, and along this we are going to study the um, types of lithography, then what are the steps in lithography, and the last topic we will study today is the challenges in macro and nano fabrication techniques. So this lithography, we start our chapter macro machining and fabrication, from where we just start with diamond tool machining, then ultrasonic micro machining, where we are just focusing the application on the mechanical field only. But this lithography is directly related with the robotics or nano fabrication or nanotechnology revolution. This is the today's era is the era of nanotechnology. So lithography bears an importance in nanotechnology. So it is the important part which we are going to study. There is always a question related to lithography is asked in the examination, that write a short note on lithography. The question is of 4 marks, and many times is asked for 4 marks, not more than this they are asked, and the question is simple, that write a short note on lithography. So let's get started. Focus on what I am writing here on this slide. It is an art and science of producing a pattern on substrate. Then what is pattern, what is substrate? In mechanical things, we show this pattern on the during the cutting section of the workpiece. Then you saw the cutting section of various some tools, some product, then of wood, cross section, transverse section. But here it is the science of producing a pattern on substrate. But substrate we are focusing on the, just keep in mind that IC, integrated circuit boards. What you saw on integrated circuit boards, there are some circuits which are very minute in lines and which are connected. Actually this is part of electronics, but just keep in focus that here is pattern, means the pattern of line they are drawn on the IC engine, sorry, IC integrated circuit board, not our IC engine, it is here integrated circuit board. Okay. Then it is a process of forming a pattern on electronic material. It is used for manufacturing integrated circuit in electronics industry. Whatever the electronics material, you always see their presence of IC, and in that IC there are some materials such as capacitor, resistance. So this capacitor, resistance, and various controlling units are connected by the a wire like material. Here we are referring it as a pattern. So to draw this pattern we are using this lithography. Okay, it is a keystone in nanotechnology evolution. Boys, this is the era of the nanotechnology. This is the most focusing point, that uh, you see that in past decade we are using the telephones which are very large in size, and now we are going to reduce the size of that telephone to the mobile, which is very short. In our mobile also there is a lot of IC integrated circuit units, and we are using it. Okay, so here we are again come to the point. uh, in electronics industry, lithography is referred as the process of forming a pattern on electronic tool. It is generally used for manufacturing integrated circuits. Lithography is process used to manufacture semiconductor device with minimized cost. Semiconductor device are also very much important in case of electronics. So to work on this semiconductors, to manufacture them on a small price, uh, reduce price, minimize price, size, and cost, we are using what? We are using lithography. Again here, several lithography approaches are used in semiconductor processing based on the types of radiation source of, such as optical lithography, also known as photolithography. Second one is electronic beam lithography, and third one is the X-ray lithography. I already mentioned these types here, types of lithography: optical, electronic, and X-ray. Then how they are going to makes lithography on the electronics circuits. We are just mentioning the method here. The first one is the substrate preparation. Substrate means if you want to prepare the IC, then this plastic board is referring here substrate. Firstly you have to prepare the substrate, then photoresist material coating. Once the substrate is prepared, then it is coated with the organic polymer known as photoresist. Okay. Substrate preparation will improve the adhesion of photoresist material to the substrate. Sometimes adhesive promoters is used to promote adhesion on the photoresist material. Okay. Then photoresist material coating. A photoresist material is changing its structure when exposed to radiation. The improved photoresist control, the reaction is polymer to have optimum control. A uniform layer of photoresist is applied on a wafer substrate by using the spinning method at several thousand rpm as shown in. Typical photoresist layer thickness is maintained between 0.5 to 0.25 nanometers. 1 nanometers I have already explained in the last lecture, it is 10 to the power minus 9. A photoresist is applied to protect the surface of the metal from the action of etching reagent. Heat and pressure are used to ensure good adhesion to the metal surface. There are two types of photoresist. One is called as positive working photoresist and another one is the negative working photoresist material. In case of positive working photoresist, where the dark region on the photo tool specifies the area that need to be etched. And in negative working photoresist, the photo tool specifies the areas that need to be protected from the etchant. Generally, a negative working photoresist is mostly used. Then here we go for the third stage, which is pre-bake. In pre-bake, the wafer to remove the solvent from the photoresist and harden it. This step is carried out on a hot plate heating to around 100 degrees centigrade. Mask preparation. The mask contains the hard copy of the pattern. The mask consists of flat plate of transparent glass into which a thin film of apex substance has been deposited in certain areas to form the desired pattern. Then another step is the alignment and exposure. The mask is aligned carefully with the wafer substrate. Alignment of the mask must be done with high precision and special optical instruments are used for this purpose. The photoresist is then exposed to UV radiation through mask by one of three methods. First one is the contact printing, where the mask is contacted under pressure with the photoresist coating. Second one is the proximity printing, where the mask is separated from the resist coating by a distance of 10 to 25 mm. Third one is the projection printing, involve the use of high quality lens or mirror system to project the image through the mark on the wafer substrate. Okay. The next step is of developing. The mild alkaline solution dissolves the regions of photoresist which was not exposed to UV radiation. Therefore, metal is exposed in this region, whereas the regions of photoresist which was exposed to UV radiation remains intact. Developing is usually a wet chemical process. The wafer are immersed in the developing solution for a fixed time until the resist is completely removed, having the wafer material SiO2 uncovered. Etching. In the etching process, etchant dissolved the exposed SiO2 while SiO2 which was protected by photoresist remains unaffected. The depth of each feature depends upon reaction time. Okay. Next one is the stripping. This is the last process of our lithography. In this what we are doing, At the end of etching process, photoresist material of the paper is removed by liquid chemical, which is mixture on sulfuric acid and hydrogen peroxide, H2SO4 and H2O2. The process uses liquid chemical thus called as wet stripping. Dry stripping uses plasma etching with oxygen as a reactive gas. Then there are another techniques to produce lithography. First one is the electron beam lithography and another one is the X-ray lithography. Just took a short look on this. That electron beam lithography uses a high current density electron beam as a source. Okay, and electron beam lithography is superior than optical lithography as the resolution obtained in electron beam lithography is better as compared to optical lithography. High current density electron beam is directed on the wafer substrate, therefore no masking is required. However, the system is expensive and operation is time consuming. Another one is the source X-ray lithography. This is the third type. We saw until now optical, electron, and this is the X-ray lithography. The source of radiation is X-ray, which is having a shorter wavelength in the range of 0.4 to 4 nanometer generated by the synchronous source. The X-ray is having a very large depth of focus than UV rays. The wafer substrate is coated with X-ray resist material. The mask material is a thin film of gold or a beryllium generally used. Despite having good resolution capabilities, the overall system is expensive. Okay. Then this is again just short introduction of lithography. It is the art of science of producing pattern on the substrate. In electronic industry, lithography is referred as a process of forming pattern on electronic material. Lithography is generally used for manufacturing of integrated circuits. I already mentioned it as IC units in electronic industry. Types are three types: electronics, electrobeam, and X-ray lithography. Then we are coming to the last point of our today's section, that which is challenges in micro and nano fabrication techniques. Listen carefully, guys. This is the question they many times ask in the examination, that explain the challenges in micro and nano fabrication process. Question itself carries 6 marks, so you have to write the 6 point. In short, I already written here that equipment are expensive. Standardization is required to carry out the process. Third one is the have to use at integrated process with conventional process. It is the integrated process, so it is not a special one. You have to integrate it with the conventional process. Fourth one is the more study and investigation required. Effort are needed to reduce cost of the equipment, and finally is the tools are expensive. Now listen, I am explaining this one by one. That micro and nano fabrication have been one of the most important development in manufacturing field in the last decade. The drivers of micro and nano fabrication research are mainly the demand from semiconductor industry, electronics industry, aerospace sector, data storage, biomedical and optical industries. However, many challenges are existed in micro and nano fabrication techniques, such as high cost process equipment. Currently, some of the equipment is expensive, thus mainly used for the research purpose. Efforts are needed to reduce the cost of such equipment. Standardization of material, process, produce, design and facility design. Micro and nano fabrication techniques are very precise and significantly affected by the environmental condition. Therefore, facility design standardization needs to define and to adopt suitable environmental conditions. Moreover, for uniform and mass production across the different facilities, the standard process of the selection of material, process, product design needs to be adapted. Micro and nano fabrication techniques can be used with the integrated of conventional manufacturing methods for the better surface finish and achieving desired micro nano feature in the final product. Micro nano wear and damage failure of micro Manufacturing tools need to be studied more and the knowledge generated should be transferred to the tool design and fabrication, especially the surface treatment of the tools. Okay. Here we again start that micro and nano wear damage failure of micro manufacturing tools used to be studied more and the knowledge generated should be transferred to the tool design fabrication, especially surface treatment of the tool. Characterization of micro nanomaterial and metrology for the manufactured product is still expensive. Efforts are needed to reduce the cost of such equipment. To enable mass production of micro and nano products, online inspection at is still challenging, which can be met with the high rate of production. Manufacturing of micro tools and tool holders for different micro and nano fabrication techniques is expensive one. So here is the chapter ended here. Just today we mostly take the two topics. First one is the lithography and another one is the challenges in macro and nano fabrication techniques. Both the topics are important one. Just focus and while preparing these two topics, just focus on the question by which what they are asking. If they are asking write a short note, then answer in the form of short note. And if they are asking writing while challenges in the micro and fabrication process, don't write in the form of paragraph, write in the form of point as I am writing here, and it is okay. Stay home, stay safe. I hope to see you soon, and we will take a more concept in the last lecture. Today's section is ended here. Thank you.